Hello, students. Yesterday, we started talking about cycles in general and the idea and the concept of what cycles are and the different kinds of general cycles that exist. Well, today, we're going to be taking things a step further and a step deeper as we talk more specifically about cycles of matter. Cycles of matter. And this totally ties into our topic name, by the way, the biogeochemical cycles. Cycles of matter broadly describes the flow of matter, namely chemicals, through biotic, the living, to abiotic, the non living parts of an ecosystem. The very topic name itself, the biogeochemical cycles, describes this definition of cycles of matter. The flow of matter, the chemicals through the biotic or the living to the abiotic or non-living parts of an ecosystem. And today we're going to be exploring a variety of specific cycles of matter, starting with one that you're probably all familiar with, but moving on to ones that you're probably much less familiar with. So let's continue as we discuss the water cycle. How many of you have ever heard of the water cycle before? Yeah, everybody has, sure. Well, the water cycle is more technically known as the hydrologic cycle. That word, hydrologic, what does that refer to? It refers to water. Okay, so the water cycle, also known as the hydrologic cycle, is illustrated in this diagram, and I want you to notice the shape of the cycle. It goes around and around and around again because that's what cycles do. But there are different parts of this cycle, and we have to start somewhere, even though we can choose any one of the parts of the cycle as a starting point. Let us begin with evaporation. Evaporation is when you have a liquid, and in our case, talking about the water cycle or hydrologic cycle, the liquid that we're talking about is water. However, this cycle, this liquid cycle, does take place elsewhere in the solar system, and things other than water are cycled through an environment. But we'll save that for astronomy later in the year. So, evaporation is when a liquid changes to a gas. And that takes energy for that to happen. And that energy is supplied on planet Earth by our friendly neighborhood star that we call the sun. So the sun provides energy, and when it shines on water bodies, whether they are lakes, streams, or the very oceans themselves on planet Earth, when enough energy is received by the sun, that liquid water evaporates and goes into the atmosphere as a gas. And that gas is called water vapor. Now, when that gas goes high enough into the atmosphere, that gas begins to cool because the higher you go in, at least the lower part of the atmosphere, which is called the troposphere, as you go higher in the troposphere, the temperature decreases. And as the temperature decreases, that energy is removed from that water vapor. And as a result, we get the formation of clouds due to condensation. Condensation is what happens when a gas changes back to a liquid. So, evaporation, we go from a liquid to a gas. Condensation, we're going from a gas back to a liquid. And when that happens around small particles of dust in the air, it forms droplets of water that, when they are found, billions of them together in one place, we see that from the surface of the earth as cloud formation. So clouds form through condensation. Hey, they both start with the letter C. Cloud formation, condensation, condensation, cloud formation. Maybe that's how we can remember that. All right, but it doesn't end there. The cycle continues because when that cloud becomes heavy enough, or more specifically, when the droplets of condensation become big enough that their mass is too much for the wind to hold it up anymore, they're going to fall down. So that condensation, when it gets too heavy, will begin to fall. Now, it can fall in different forms based on the temperature. But however it falls, we call it precipitation. Precipitation can include rain, snow, sleet, hail, fog. All of these are forms of precipitation. And again, based on the temperature of the atmosphere through which the condensation, or rather the precipitation, is falling, will determine whether it's going to be rain or snow, or sleet or hail. Later on, we're going to be focusing on weather and climate. It's a later topic, and we'll talk specifically about these different columns of air temperatures and the type of precipitation that results. But for our purposes right now, talking about the hydrologic cycle, it's enough for us to know that precipitation follows condensation. Now, here's an interesting part of the hydrologic cycle. It's called infiltration and runoff. Now, the runoff part probably is self-explanatory, because when it rains, for instance, when it rains, the water will run off the surface of the earth into a stream or other water body. We can see that happening. But what we can't see happening as easily is the fact that some of that moisture, some of that precipitation, some of that rain will undergo infiltration. What is that? Well, infiltration is what happens when water goes into the ground. Now, in this part of the state where we live, most of us depend upon well water. And our well water is dependent upon the rate of infiltration. In other words, we have to have a certain amount of rain falling down onto the ground, and the ground has to absorb that moisture, and gravity pulls it down into a reservoir under the ground called an aquifer. And that has to happen at a faster rate than we suck the water out. I mean, think of this for a moment. Imagine having your most favorite chocolate shake, with little bits of chocolate in it. Oh boy, doesn't that sound good? Well, if you just suck through the straw, which is like a well for well water, and you just keep on sucking and sucking, well, first of all, you're going to get brain freeze, so slow down, buddy, all right? But if you keep on sucking up the that yummy shake, eventually the cup is going to end up dry. You're going to empty it out. However, if you go to one of those machines that will refill it, that's like infiltration for groundwater. It has to be refilled every time it rains. Otherwise, the aquifer will go dry. And the more homes we have in an area pulling more well water out of the ground, it depletes the groundwater supply. So if you live in an area where there's well water, you should know something about infiltration. Very important point. So here's a diagram including all of these parts of the water cycle. So it's quiz time now. I am going to point to an arrow, and I would like you, based on your knowledge so far, to call out loudly what part of the water cycle or hydrologic cycle am I pointing to. Are you ready? here we go. So our first arrow is, everybody, what part of the water cycle is this? Hopefully you said evaporation. Next, condensation. Next, precipitation. And finally, runoff and infiltration. And the cycle just keeps on going around and around and around, just like the wheels on a bus go round and round all through the town. All right, so that is the water cycle, probably the one you're most familiar with. So let's move on to another. The next one is called the oxygen carbon cycle. And in the oxygen carbon cycle, you'll see there are some key players here. We've got the happy little sunshine, we've got a tree representing all plants, and we've got a diagram of the human body's insides, namely our cardiovascular system with our lungs representing all animals. So these are the three basic components of the oxygen carbon cycle. And you will notice that we, as a mammal, as animals, we produce carbon dioxide gas as a waste product. Plants, in this case trees, with the help of sunlight, undergo photosynthesis and produce oxygen. And oxygen is produced by the plants. We consume it and we produce carbon dioxide, which the plants need. And the cycle repeats itself over and over again. So the oxygen cycle is a cycle that goes from oxygen to carbon dioxide. And the key component of this is photosynthesis. Photosynthesis is what autotrophs or plants do, and these plants take the carbon dioxide in order to produce oxygen, and the opposite of that is the carbon cycle, where carbon dioxide is taken from the oxygen. And consumers undergo respiration, and we take the oxygen and we produce carbon dioxide as a result. And that would be the byproduct. So, just to recap there, the oxygen carbon cycle, we've got photosynthesis and we've got consumers going through the oxygen cycle from oxygen to carbon dioxide, through photosynthesis, and the carbon cycle, carbon dioxide from oxygen, the O2, and that's called respiration. So that is the oxygen carbon cycle, another very important part of the cycles of nature. All right, so once again, here we have our diagram. We've got the sunshine providing the sunlight required for producers to undergo photosynthesis, producing oxygen, then consumers take that oxygen and produce carbon dioxide. So, what is waste for one is necessary for another. That's what makes it a great cycle. All right, here's my favorite, the nitrogen cycle. The nitrogen cycle, if you notice, there are a few key components here to the nitrogen cycle. Here we have our friendly cow undergoing metabolism. We've got a thunder and lightning storm. What is that all about? Well, we're going to talk about the nitrogen cycle one part at a time, but let's just soak in this picture first. You see, our atmosphere has a lot of what's called free nitrogen. Not that it costs anything. The vast majority of our atmosphere, about 78% of our atmosphere, is in fact nitrogen. And we don't really breathe in, we're breathing in nitrogen all the time, but we can't use the nitrogen that's in the air. It's of no use to us when it's called free nitrogen. something has to happen, and that is called fixation. Not that nitrogen was broken in the first place, but it has to be fixed by organisms that are capable of doing so. And we're going to be talking about those organisms, namely bacteria, on the roots of certain plants. And then those plants take the nitrogen and fix it in amino acids, certain chemicals in the plants that are eaten by animals such as cows, and it undergoes metabolism. And we also eat plants with nitrogen compounds in it that we need as well. And then through metabolism, we released waste material like these cow pies here, and the decomposition of that waste then releases, through the process of decomposition, releases free nitrogen into the atmosphere once again. So let's put this into words in our notes. So the beginning part of the nitrogen cycle is called fixation. Fixation is when bacteria changes the free nitrogen from the air to nitrogen compounds in the soil. And these typically take place in the roots of plants. In fact, some plants are much better at this than other plants. Legumes are really good at fixing nitrogen. Clover is really good at fixing nitrogen. I think soybeans also are pretty good at fixing nitrogen. And so farmers, if they have fields and undergo crop rotation, they actually change their crops from one year to another in order to allow the the fixation of nitrogen to take place that benefits not only the soil but the other crops that are growing. Now, there's another source of fixation that doesn't involve the bacteria found on the roots of plants, and that's in lightning. Lightning can also fix nitrogen or chemically combine it with other elements in the atmosphere to make it more usable by organisms. Have you ever noticed that sweet pungent aroma in the air after a thunder and lightning storm? It's because the lightning itself, the energy from the lightning, is changing the chemistry of the atmosphere. All right. Metabolizing. Organisms do this with the nitrogen compounds that are found in the plants after the roots have taken advantage of the bacteria in them. But metabolizing takes place in the consumers, and the nitrogen compounds are moved from the soil to the plants to the animals. We are so dependent, we as consumers are so dependent on some of those nutrients and minerals that are found from plants that we can only get from plants. And without them, we would eventually die. So we are very dependent on the nitrogen cycle. When we're done using those nitrogen compounds, and we use them in various forms within every cell of our body, and we produce waste material, well, that waste material, including our own bodies when we die, undergo decomposition. And during that decomposition, the bacteria are free to free the nitrogen back into the air once again. So again, the illustration here of nitrogen cycle, I'm going to point to an arrow, and I'd like you to call out what part of the nitrogen cycle am I pointing to. So let's begin with this arrow. That's called nitrogen fixation. We're fixing the nitrogen. And with these arrows, what are these referring to? Metabolism. And then finally, this arrow describes decomposition. So there we have discussed several of the cycles found in the topic of biogeochemical cycles. Tomorrow, we're going to finish up with one last part of this topic by discussing something called ecological succession. But for now, I'll simply say bye bye.